Welcome to a new video on my home automation OpenHub and NodeRed series. In this video I want to follow the topic that I've started previously when I showed you how you can build a DIY thermostat using an ESP8266 board, an OLED screen and using ESP-Easy. And today I want to show you this commercially available thermostat which uses the Modbus protocol, and we will see how we can hook it up to NodeRed, how we can read the information which is set on this screen, and how we can control it also from NodeRed. And in this video I also want to use a nice component that I stumbled upon on the internet, which simulates the Nest look and feel as the user interface, and use that as the thermostat interface within NodeRed. My father-in-law works in industrial automation, and about a year ago I think they received a project where they had to do a complete automation of a small hotel, including the heating, the ventilation, cooling, lights, the pools and the sauna and the jacuzzi and everything. And I helped them to source this thermostat from a Chinese supplier called Beca, or Beca Energy. And I don't remember the exact figures, but it was, close to $20 a piece. I think we ordered around 40 or something. And of course that's, without shipping and the usual customs and VAT which comes when it gets imported. But still, it was a really, really good product. I think a really nice looking product. And it was definitely less than half price of the main brands that are available here locally. So my father-in-law was also very happy. And because we ordered a few extra, I just asked for one of them. And it's been sitting on my shelf for quite some time. And since I've done this video on the thermostat, I thought, well, maybe I should give it a try. I've used Modbus before, so this shouldn't be a big challenge. But before we start, let me just show you the whole thing. So as you can see, it is designed to go into a wall socket. It has quite a few different terminals. We are going to look at it later. And then on the front, we have some sort of front cover, and also we have the front user interface, which is designed to be modular, so it comes apart. And then once we are going to go into the website, you will see that they have many different models available. So there is one which has this white ring. This ring is available in black as well. There is one which is more like a square form factor, not the round one. So they have quite a few designs. So I believe that they manufacture quite a few of the different front ends and the screens, and then they also manufacture different backs as well, and they are sort of compatible because this particular unit is designed for a fan coil system. So as you can see, there is a valve which will allow you to control the heat, the hot water or the cold water, which is going to do the heating or the cooling, and there is a separate output for fans. So you can see it here. But they have different models for different fan coil types, 2-wire or 4-wire. I don't even know all these details. But there are also models for boilers. So if you have a normal gas or electric boiler, and you have a normal wall thermostat, which is basically like a dry contact, you can get the exact same model, the one that looks exactly like this, but it uses a dry contact. So they have different terminals, and they are basically using different screens, and they just have these terminals to do different things. And you can see some of these in the box as well, so the few different versions that are listed here. And by the way, they do have some Wi-Fi model as well, which comes with a bespoke app. But if you want to do like a custom control and you want to use NodeRed or any other home automation system, I think probably Modbus is the most versatile one. Even though somebody will say that, okay, Modbus is an old industrial protocol, but it is actually quite easy to use it in modern, like this open source systems, and I'm going to show you how. In the box we are getting 2 leaflets. One of them is a user manual. If you want to read the details, you can pause the video. You have the specs here. You can already see the different models that they manufacture for fan coil operation or the fan coil heating, and then you can see the different visual designs as well. And on the other side there is the actual operation, how you use it, how you can program it, how you can do certain stuff, and there are a couple of functions as well, some like system settings and defaults that you can set on the screen as well. And surprisingly, there is a second documentation in the box as well, which describes the Modbus protocol. And using the device is remarkably easy because they have only implemented two Modbus functions. The first one is function 3, which is to read, I believe this is read a register, and they have clearly marked all the different registers that they have, and they only have 10 registers, so again, quite simple. And you can also write most of these registers, for which you are just simply using function 6 to write a single register. And just like with many Modbus devices, the temperature is stored in 0.1 centigrade. For this demo, I just used a small plug, which I connected to the mains terminal. So that is going to provide power for this device. And to the Modbus lines, I have connected this USB to RS485 converter, which I got from China. And I got it a long time ago, so hopefully I will be able to find the link and put it into the video description. But it was one of these generic USB to RS485 converters, and then all you have on the other side is you have connectors or terminals which says A and B, and also the A says D plus and the B says D minus. So I connected the D plus to the red, so those are the lines like that, and I just plugged it in and it worked. So I have the device connected to the mains power. At the moment, it's not connected to the computer or anything on the Modbus side. And as you can see, it's measuring the temperature. Oh, actually, this appears to be the temperature sensor because it just got it was just going up. So it's measuring the ambient temperature, and if I use the up and the down arrows, then I can change the set temperature, obviously. And by the way, all these buttons are touch capacitive buttons, so they are touch sensitive. If I go back to the controls, on the top you have the on-off, so you can switch the device off, and it doesn't only switch the screen off, but it actually switches the device off. So if it was on, as in like the heating was on, when you switch it off, it actually turns the heating off as well. So you do on and off here. The second button is the mode button. As you can see, I have increased the ambient or the set temperature above the ambient temperature, so the relay is on now, so the pump is pumping, and soon probably it will just, if I go below, then it's going to turn off the pump, or not, sorry, not the pump, the valve. And as you can see, it is actually a thermostat, so it does all the basic operation like turning on and off on its own, so it doesn't need Modbus or any other external device to operate. But then you can use Modbus to read all the values out, and also, you know, make change all these values. Obviously not the ambient temperature, but the target temperature and all the other stuff. There is also a real-time clock which gets reset when the power is lost. So this is why it's showing 2 minutes after midnight and 1, which is probably Monday. So you can do some programming, like, you know, different temperature profiles for weekdays and weekends and that sort of stuff. On the mode button, you can switch between the different modes. So because it's a fan coil controller, it has all the 3 modes, so cooling, heating and simple ventilation. And you also have a fan button, so you can control the fan speed, and it goes between high, medium and low and auto. Of course, you can set the clock and you can change the programming, but I'm not going to go into that details. If you are really interested, you can, you know, read the user manual. And you can also change the settings on this device. And you do that first, you power the device off to turn it off, and then you press the ventilation and the mode button together. And now you can see the different modes. And then you have a couple of values which are indicated here. So this is value 2, 3, and okay, I need to go back. So you don't do anything, it goes out of the settings mode. So you have the different modes, the values 1, 2, 3, so those are the small numbers, and the actual value is here. And you can read the documentation which each of them does. The one I was most interested in is value D, which is the Modbus address, and by default it is 1, and I changed it to 5 because I wanted to see how easy it is to change the Modbus address. And so you can change the Modbus address or the slave ID on the device. The communication protocol, like the speed and everything else, is fixed, so that's what you have.
As I mentioned previously, Beca creates many different versions of these thermostats. They are different in terms of the visual appearance, whether they are round or rectangular. You can see a couple of examples here, but they also differ based on the type of application. So if you head into here or head over here and then click on products, you can see that there are various versions for fan coil, if you have fan coils, or if you have other heating thermostats. And in the heating, again, you can have water heating, electric heating, radiator thermostats, or boiler thermostats. So if I click on the boiler one, then again you can see that you can have different versions, the round and the rectangular ones with white bezel or black bezel. And since I only work with this single model, I can just assume that the innards, the internal workings, and the Modbus and the registers are probably the same for all of these. They just have a different, physical front-end design, like the screen and the buttons, and they have different designs at the back, whether it's a fan coil one or a boiler thermostat. And even if I look at the first one, for example, this is BHT 6000, that would be a water or gas boiler heater room thermostat. And if I scroll down, then even here I can see that there are several subversions. Whether you are controlling your boiler based on using a dry contact, or whether you are actually switching the load inside the probably a water heater, I guess, or you are controlling some sort of valve and your boiler works independently. So again, just head over here, look at the different products, and then choose the one which is most appropriate for your particular installation. I'm going to leave the link of this page in the video description, and I was also provided a couple of Amazon links to various Amazon stores. So if you are interested in buying something via Amazon, for example a one-off, then probably you should do it there, because with the shipping and customs and everything, it would be probably cheaper than ordering a one-off directly from China. Before we start looking into NodeRed, I think we should go into Modbus, and that's the application which I usually use to look at different Modbus devices. And you can even download a trial version of this from the web. So here I have the thermostat powered from the mains, and I have connected it to my USB port on my laptop using that USB to RS845 converter that I've shown previously. So the only thing we have to do now is go to connection and connect. It has already identified that I have a USB device on COM4, and these are the connection settings that I need to set for this particular device, and I just need to click on OK. We are getting a timeout error now, but if you are using this device out of the box, you actually wouldn't going to get a timeout error. But I have changed the Modbus address, or the slave address of this device, or the slave ID. So here again in setup and read write functions, I can change the slave ID to 5. That's the ID that I set it to my device. And by default, it is using holding registers as a default Modbus function, and reading from address 010 addresses, and doing it every 1 second. So if I do that, then we can already see that we have some numbers coming through from the device. And just by looking at the numbers, we can pretty much tell what each number represents. So for example, if you look at the screen, 21.5, so that's 215. As I said, the temperatures in Modbus are usually times 10 of the actual temperatures. So they don't have to store the numbers in some complicated floating point value. And they are only using just 1 decimal place for temperatures. So that's my room temperature. And if I change the set temperature using the up-down arrows, you can see that the set temperature is 26. So that's 260 here. If I update it, you can see it changes as well. And basically using, changing stuff around the screen, you can pretty much tell what each register stores. And of course you have the documentation. So for example, whether the unit is on and off, it's stored in in the register 0. And then if I cycle the mode, you can see that this number goes up and down. If I cycle the fan speed, you can see this number going up and down. And if you see the time is 0 hours 20 minutes and the first day of the week, so that's 0:21. And for example, bit 9, or sorry, register 9 is whether the relay is on. So if I change it to heating mode, my set temperature is higher than the room temperature, so the relay is going to come on, and as you can see, register 9 also changes to 0. And based on my experience, I also know that register 4 is screen lock. I would say that's pretty much about it. I mean, it's not really a complicated device. We don't have a whole load of registers that we have to remember, and the way the values are stored in these registers are also quite easy. So we can just head over to NodeRed and see how we make this work under NodeRed. But before we jump over to NodeRed, I just want to talk a little bit about this blog post, which you can find on notenouughtech.com, and probably it was featured on many other places. And what this guy has done is, I quite like it, is that he has used a widget which looks like a Nest thermostat, or the face of the Nest thermostat, and used that within NodeRed flow. And also just integrated here F-Sonoff and some temperature sensor with his old Honeywell thermostat. So, and I quite like the idea. I mean, why I like the visual appearance of this Nest control. So I thought I'm going to use this in my demonstrations as well. I had to slightly rearrange my setup. So the thermostat is moved much closer to the Pi, and basically all I have done is I've taken the exact same USB converter and plugged it into one of the 3 ports of the Pi, and that's it. Of course, it uses the CH340 chip, which is automatically recognized as a USB device by the Linux system, so I don't have anything to do. There is no need to install drivers. You just plug it in and it works. And we are going to look at it, how it actually communicates. But first, let's look at the Nest thermostat in the beginning, because that's on the top of the flow. So I'm just going to deal with that first. And this is how the screen looks like at the moment. As you can see, I'm using the Nest thermostat as a display for the current temperature and the set temperature. So the target temperature is 21.5 and the current temperature is 23 degrees. I have a slider where I can change the set temperature. And also, it's not really obvious, but the way that you can also use this control to change the set temperature. But the way you do that is you click and hold the mouse for 1 second, then you can see this ring appearing, and then when you slide your mouse left and right, you can change the set temperature. And as you can see, I've done it in a way that it updates the slider as well, and it also updates this screen, which is actually the data coming back from the Modbus device. So you always see a little bit of delay, because when you change something here or using the slider, the information sent over to the thermostats via Modbus, and then in the next update cycle, which in my case is every second, then I'm getting the readings back. And these are all the readings that are coming back from the device, and this is based on those 10 registers that you have seen previously in the Modbus post. So ambient temperature, target temperature, we have the power. So if I turn it off, then you can see that the power goes off, and it also updates the Nest image, so it appears gray as in off. If I turn it back on, then it comes back on. We have fan speed, the mode, and we also have the time, and whether the valve is closed or open, and if the screen is locked or unlocked. And then here I can also make some changes. So besides the changing the target temperature, which I do here, I can also power it on and off from here. And then you can see all the things update automatically. Again, the reason the Nest image updates a little bit later, because that is again based on the information coming back from Modbus. So the 1 second delay is actually the time it takes for the data to go over to the device via a Modbus, and also until the next update comes through in the next second. So yeah, you can change the fan speed. Yeah, now it's high, you don't see any changes here. But if you change the mode, for example, to cooling, then the Nest also changes to blue, which is how it does. And then finally we have the lock, which you can see on the screen now. So you can see the small lock symbol. And that's what I have done so far. So besides giving you the controls and the overview of the data, and then having the NodeRed and the Modbus device synchronized. This flow is not doing anything else at the moment. I'm still working some sort of flow within NodeRed where you can, have different heating patterns and choose them for different days, but that's going to be in an upcoming video. Let me just put it back to, let's say, heating and unlock, and I think that's going to be fine for the time being. And let's see how the flow works. So as I said, let me deal with the next Nest controller first. I have taken that part of the flow from an example. So that's the UI template, which controls all the HTML and JavaScript code which is required to make this Nest controller work. It's quite an extensive bit of code, so there's a lot of stuff in here, but that basically draws the various part of the image and also responsible for feeding the data in when you are trying to change the temperature, which comes out as a message at the end. And also you can see some examples here, which was again taken from the example code. So how you send a message to change the ambient temperature, the target temperature, the HVAC state, which can be off, heating or cooling, and the leaf symbol and the away. So I'm not using away at the moment. Oh, by the way, but I'm using leaf because I said if it's set to ventilation, then ventilation is a leaf for me because, well, you're not using that much energy, so it's energy saving. But let me just put it back to heating. So all these messages going into this UI template node, and that is responsible for updating the control on the screen. So that's fine. And anything which comes out of it is whenever you change temperature. So we have to deal with that. Without explaining much in the middle, let me jump a little bit further back, which is all about the Modbus part. As you have seen in Modbus poll, reading this device is quite easy because you just use function 3 and you read the first 10 registers and you will have all the data that you need. And that's exactly what I'm doing here. So I have, oh, by the way, if you haven't used Modbus before, for this one I'm using this NodeRed Contrib Modbus, which, by the way, there is a newer version, so I should update. And because I'm using Modbus OS Serial, I also had to install this one, which is NodeRed Node Serial Port. This node is part of the Modbus nodes, and we have quite a few different options. I mean, for this one, it's a Modbus read, so I'm using this Modbus read node. And when you place it here, you have a couple of things that you can set. The first one is obviously to set the server. And here I already have two different servers set up because I actually have two serial or USB to RS-845 converters plugged into the Pi. So this is just a proof that you can have multiple of these devices. Well, ideally I could have used one because you can chain multiple devices in one single Modbus line, but for this I decided to use the second one. So if I go into the configuration, I just named it second serial 9608N1, and we are using serial and then the device. So I have a couple of USB devices plugged in. So this is /dev/tty USB 2, and I'm using RTU buffered 9600, and rest of the things are left as default. So there is a timeout and a reconnect, and there is a queue command, and yeah, queue delay 1 millisecond. That's it. So that's about the server. And then the devices, I just named it to Beca. I haven't changed anything in the topic. Unit ID is saved as the slave ID. So by default, this is 1. I've changed mine to 5. We are using Modbus function 3. And it is exactly the same setup as in Modbus poll. So we are using address 1 and quantity 10. So we are reading the first 10 addresses. And also here we are updating every second. Well, obviously you can choose this into a less frequent update if your setup is working reliably. But again, that will impact how quickly for example, your dashboard updates after you have made any changes on the device. I haven't changed anything in the options, so that's pretty much default. So that's all about the Modbus line. And once you have done that, the information which comes out of this node is basically the array of the various registers that we are reading out of the Modbus device. Again, the same list which comes out, which we have seen in Modbus Pole. And this is all fine, you can use this information, but I also needed to convert some of these values. So for example, divide the temperatures by 10 degrees and so on. So I'm just passing everything through this connect, so this convert a node which slices the data up and puts it into various attributes of the message. And also for some of the ones that have options, for example the fan speed, the actual values have some meanings. I've also created these fan attributes where you can see the actual values, so whether it's low, medium, high, or cooling, ventilation, or locked and unlocked. And that information basically just goes into the various display elements on the UI. So we are displaying the values, and for example, for fan speed and mode, I'm displaying the text values instead of the actual number values, but you can find them in the... And also using these bits here, I am updating the controls where you can change the values. So for example, these two drop downs and these two switches. And here, the only thing I have done is this node remembers the value of these, for example here the power value, and it only passes the message through if it changes, because without this, when you start making changes in the, for example in the drop down or in the slider, whenever a new message comes through, it basically overrides these changes. So you know within 1 second you have to make the change, otherwise it gets overwritten. So but by this it doesn't happen, because you only get the update once it changes. And yeah, that's pretty much it. So yeah, controlling it and reading the data and displaying is really, really simple. And again, remember, you can daisy chain as many of these sensors as you want. Well, I think there is a limit of 255 or something like that, or 200 devices on one Modbus line. But yeah, that's probably more than enough what you would ever need. And if you would have multiple devices, then you just need to multiply these nodes and along with all the display nodes, and change the unit ID. So it will be just a different unit. The only other thing I have done, well, besides bringing the data in, is, even though it's not clearly mentioned in the documentation, but I just realized that, well, because I can read all the time and the date values, which by the way I'm displaying here as well, what if I can just write the same values? So I can use the system time and the actual date and time of the Raspberry Pi to update the time on the Modbus device as well. And of course you can change the time and the day of the week using the buttons, but it will be much easier if NodeRed does it automatically. So I have this very simple flow here. So you click here, and you should see on the screen that the time is updated. And today happens to be Monday, so this number 1 hasn't changed, but believe me, that is updated correctly as well. So that's it. So this is all the update and the update part of it, which is basically responsible for this Beca and this Beca control group on NodeRed. And I have a few more things here which update the Nest control. So I'm using the ambient temperature, the target temperature, the mode, and the power to control the Nest display. Obviously the two temperatures are being displayed here, and the power and the various modes control the color and the leaf icon on the Nest screen that we have already seen before. And that is what's being done over here. So again, in the ambient temperature, I'm just creating a new message which I'm putting a specific topic, and the payload is the ambient temperature. And I just had to create a new object, because I realized that if the actual message contains more attributes, then for some reason the Nest control doesn't accept it. So I actually had to do this, had to create a new message which only has a topic and a payload, otherwise it doesn't work. So the same for the target temperature. And again, here the control remembers what was the previous target temperature and only updates the nest control when there is a change in the temperature. And again, that's just so that the NodeRed or the dashboard update works. And the state and the leaf is basically dependent on the cooling and the heating, whether it's cooling or heating. And the leaf is, again, it's if I have the mode set to 2, which is ventilation, then I turn on the leaf signal. And finally, setting the target temperature. So this target temperature also comes to the slider, which is this slider just below the screen, or the Nest thermostat. And if this slider changes, or if the target temperature is changed on the Nest thermostat, then the information comes through here. It is getting converted, which is basically times the value by 10, and then it goes to an update, which is a Modbus update. So again, unit 5, we are using function 6, which is update a single register, and the register for the temperature is 3. That's it. You send the value through, it goes to the Modbus, and it updates the device. And this function and this line, so that basically this path of the message updates the Nest thermostats immediately when you change the target temperature here. And of course, that gets updated once more when the data comes back from the Modbus device as well. So I think I have covered all the different options of setting temperatures, reading data, and then also writing data. And of course, by the way, I haven't talked about this, but if you change the power, the fan speed, or the mode, or the lock function, or lock slider here, that each of them update the particular register on the Modbus device. So these are all Modbus writes. And as you can see, unit ID 5, function 6, the only difference is the address. So power is address 0, fan speed is address 1, mode is address 2, and the lock is address 4 if I remember. Yeah, that's address 4. So that's all there is to it. This was my quick video of integrating a Beca thermostat with NodeRed and establishing a two-way communication between the Modbus device and NodeRed. As usual, you can find the link to this flow in the video description. Thanks for watching, and hopefully see you in the next video.